Hello? Alright, so this is a quick demo of how STOIC works. So basically we have two parts of STOIC. One is the socket client, another one is socket server. The server collects the image data from the camera and locally decide whether to run it on the edge cloud or package all the image and pass to the Mayhem cloud where the client is running on. The client then, as a relay, transfer the image to the Netless cloud, and then when it finished the job and then retrieve all the results and pass it back to the edge cloud in terms of the time and also the inference result. So let me show you how it works. So let me start the client first. So you can see it listened to the port 5001. And actually, these are two virtual machines on the Mayhem Cloud right now, because we don't really have a cluster in Cedric Reserve, but in the future, the server is supposed to run in the Cedric future, but the underlying mechanism is totally the same. And then let me start the server. So you can see in this batch, we have 41 images, and this request the Raspberry Pi in the Cedric reserve, and right now it has about 29 megabits bandwidth. So it takes around 2.3 seconds to transfer, and then it calculates the runtime of this four runtime scenarios. GPU 1, GPU 2, CPU, and Eucalyptus, and then it says, okay, because GPU 1 used the least time to run this test, so let's schedule it on the GPU 1, and then they will send it to the client. Then the client will say, okay, right now we have two GPU in our pod, so let's downgrade it to 1. So it will downgrade it and deploy the kubeless function again. And while it's progressing, it just wait there until it is successfully progressed, and then it will send a request. So this is another feature. So because the function has been newly deployed, so we want to avoid the cold start issue. So we probe this pod by only one image and make them to retrieve the model and to set up the TensorFlow framework to make it fully ready for the new coming images. And then after that, it will say, okay, it finished probing. Right now, we are ready for the real job. So okay, you can see right now it's finished. There's 41 images retrieving. It takes about 78 seconds to do it, and then it passes this information back to the server. The server recorded and say, okay, right now we have 41 images, inferenced, and has one batch, and we have 96 seconds, to do this task, and all these three numbers will be accumulated along the way. And after that, we have the next batch. So in reality, the requesting period is about 1 hour. But because it's a simulation, we just constantly, sending the request to the client as long as the previous batch has been done. So in this scenario, because the last batch has done, so we send another request, which is the 89 images. And you can see it here because the number of GPUs is not changed. So that's why we said, oh, okay, because we don't have a newly deployed pod here, so there's no probing is needed. So we don't really probe it. We just run the test directly. And then it takes about 60 seconds to run and put it back. And we add up the transfer time and the deploying time. So overall, it has 207 seconds to run this 2 batch. And you can see here, okay, we have another batch which is scheduled to GPU 1 because it's a pretty large amount of images in this batch. So we got GPU 1. If we have only single digits number of image, it will run on the spot, like this one. We only have 6 images, so it runs on Eucalyptus. You can see we don't have anything here, in the client. Clients keep listening, until this batch has been done. If we have a really large amount of images in one batch, and then it was scheduled to GPU 2. Okay, so it has done the job locally, and then for another one we have 72 images in this batch. So yeah, it's pretty forward how it works. And then these are for times are 4 times for the runtime. So we select the least time of runtime. So these two will keep running. And based on the previous experiment, we found the cross point of mini Eucalyptus and the CPU on Netlist is about 21, 22 images. The cross point of Eucalyptus CPU and a Netlist, a Netlist CPU and Netlist 1 GPU is about 42. And when we have over 95 images, and then the Netlist 2 GPU scenario wins. So this is currently what we have, and I plan to run another round of experiment for to simulate a couple of days of running. For example, like 97 or 96 batches, which mimic 4 days worth of images processing, and then we compare this result to if we only run in one scenario. For example, we run everything locally in the edge cloud, or we run everything on Netlist CPU, Netlist GPU 1, Netlist GPU 2, and our smart scheduler will definitely win over these 4 single runtime scheduler in terms of the time, and also if we want to include energy or some other metrics, we can definitely do. Okay, so this is a very small demo. Please let me know if you have any opinion on that. I'm still working on the experiment. I will keep you updated. Thank you.